All right, welcome back. We are OOP3200 in the fall 2020 semester at Durham College, and it's week 12, part 1 of our broadcast. It's all around Java again, inheritance, packages, and access today. Let's take a look at our schedule. So this week, in-class exercise 11 is due Friday. That's something that we're doing today. Java Lab 3 is due Sunday, so that's to be done in pairs again as normal. We are going to talk about Java packages very briefly today, as well as touch upon polymorphism. I'm getting this early to you because you're going to need to do it, especially for some parts of your assignment that are coming up. So where are we? We're at the bottom kind of this page. We're at week 12. We only have a couple weeks left. We only have next week, which is where we're going to be doing more overloading examples in Java, and week 14. That's it. There's 2 more weeks left, as an example, and then we're done ski, right? So lots of stuff this semester. I think most of you are doing fairly well. I've been looking at your assignments and also your exercises. I think you guys are following along nicely. And again, I think part of what we're doing here in this course is it's a little bit exploratory in that you get your C++ stuff in the first half, like we talked about. In the second half, you're just doing something very similar in Java, and at the end, I think you'll have C#, Java, and C++, and I think maybe a little bit of Python if I'm not wrong. So I think it's pretty good overall from a kind of a basis, a language basis. That's pretty good. Before we get further into the actual stuff we're talking about today, let's get into the lab that I'm going to be talking about. So this is Lab 3. So Java Lab 3, and inheritance is due on Sunday like normal. Okay, so that's kind of the stuff that we're doing. I like what's upload block stuff. Sunday, December 6th, 2020 at midnight. Value 6%. It's about inheritance. We talked about inheritance briefly last week. Max marks 100 again. Again, what you're going to be doing is you're going to be modifying your work ticket and to create something called extended work ticket. So this is again another analog along the lines of what we did with C++. So really what we're doing is we're just adding a Boolean attribute called myOpen to indicate if the work ticket is open or closed. Okay, so that's really what it is. That's what extended work ticket does. It's broken down again just like normal into accessors and mutators. So where you're going to make a accessor called isOpen, which is going to return the myOpen value, whether it's open or closed, right? As well as mutators called openTicket and closedTicket that will set the myOpen attribute, all right, to whatever it's going to be, open or closed, right, as an example. And then you're going to have 3 constructors that we're going to be looking at. The default constructor is going to initialize all inherited attributes using the default constructor from the base class, and the myOpen attribute should be initialized to true. We're going to talk about that a little bit, how to do the same things today with our examples. A parameterized constructor, as well as another one that accepts a work ticket object and a Boolean as a parameter, as opposed to just your regular other parameters. So that's kind of what we already did. We already kind of did this kind of stuff with the vector class, and we're going to extend that today. Set work ticket is a kind of a setter that we're going to be using, and you're going to overload it, and you should know how to overload it, right? By including an additional parameter to set myOpen attribute. Okay, so that's what's happening there. ToString you're going to do as well, and the rest is very similar. So I don't think there's anything that's spectacular in here in terms of your expectations, things that we've seen before. It's along the same lines in terms of the criteria. Again, due Sunday, lots and lots of time to get that done. I would start it early though, so that way it's out of the way. So that is your Java Lab 3, and that is due, like I said, on Sunday. Okay, so let's go into a little bit into Java packages, unless you guys have Any questions around the lab? I don't think so. I think it's pretty straightforward. But if you do, put up your hand here in the participants panel, and then I can respond. Okay, so we're going to talk about Java packages, and I talked briefly about Java packages in the past and how Java packages are really Java's answer to namespaces, more or less. One thing that Java expects you to do when it comes to packages in general is that they really should be in the same folder as, as an example, as the name of the package. So I got some examples here. One of the examples is a car and a truck class. So two classes, car and truck, both inside of the vehicles package. Notice that we have to put the name package at the top and then package name there. So a keyword package, package name, right? And then the way it's supposed to be done is that basically what you want to do is you want to ensure that each of the classes that you specify are in the appropriate folder. So the folder structure is really important. An example would be if car and truck classes are part of the vehicles package, they must be stored in the directory called vehicles, okay, as an example. So that's how it goes. So this is what the structure will look like. So you've got your C drive, let's say, you've got your workspace called My Packages, and then some kind of vehicle your packages workspace, your vehicles package, and inside there you have car and truck. Okay, that's how it works in terms of how Java needs that to happen. Let's try this out with live. And again, I've got I'm gonna run off of the same structure that I had from last week. So for you, I have a bit of a starter. If we go to our files here, right, in the exercise files, under in-class exercises, and again I'm looking at week 12's content, I have a GitHub repo for week 12. This is the one that you can use for in-class exercise 11, right? And it's based off of the last repo we did together, so it's it's kind of builds. If you want to use the last one too, you can, but the problem is that your GitHub link is pointing to the wrong place, and you want to make sure that you have a separate repo every time you hand stuff into me. So this is where this is, where it's at. And if you, one of the challenges we have is, again, just when you launch my project, and this is something we haven't really done together, but let me just close down this thing for a second. So here's IntelliJ. I'm just going to close it down. So let's say we're going to go to close project. One thing that you're going to get with IntelliJ is the idea for you to open or import. And what you can do is you can put in a path for opening or importing any of the packages you want, or any of the projects you download from me, right? So for example, you downloaded something from me, you can certainly put in the full path in there, and then it'll go through there and import it, okay? Especially if it's an IDEA, IntelliJ IDEA package, then it'll be totally fine. You'll be able to do that no problem. One thing to note is whenever we rename stuff, if let's say I was going to base package or lesson 11 or lesson 12 on lesson 11, I highly don't recommend you rename your module outside of IntelliJ IDEA. You're going to have some like really weird effects around this, because IntelliJ has its own XML structure for the properties of the project and so on. Think about this as your manifest, your project manifest, and it has a lot of little details. I highly just recommend you do it inside of IntelliJ itself. Okay, so we can get that done. So again, that's how you would do it, and then you're going to have something that looks like this. So let's suppose I want to import or open another module. I would swim to the folder that I want to go to. Let's say I want to open last week's, so number 11. I would go there just to this level, not in there, and then press OK, and then sure enough, there's 11, right? Let's close this project off for a second, and let's back to this. Sorry, back to this. I want to open up this one. So this is where I'm working with right now. All right, so here's my the module week 12, and I want to do this idea with you guys about packages. So let's think about how we can do that here. So notice that we have source, and we have ca.Durham College, right? Now remember what this is. Here in IntelliJ, it's showing CA and Durham College in the same spot, right? We want to make a package. Let's suppose we want to make a utility package. So CA Durham College utility, right? So utility package will include Vector2d and this random vector class, let's say, for example. So random vector, what we did last week was we created something called a singleton. And the singleton, what it does, notice the package up here, package ca.Durham College, right? We're going to extend this. We're going to move these two things into a new package. So again, here's something that I can do. I can go down in here and notice that there is a package option in here, right? So inside of my regular folder, CA Durham College, right, I could include another package up here. So let's do that. New package. Okay, and let's talk about how this package is going to be. You can put it anywhere in its spot. You can put it before Durham College, so, or after. So we normally put it after, so CA Durham College and then the package name. So let's say, for example, our package name is going to be utility. Let's put that in there. Utility. Okay. And when I do that, I have a utility package, right? There it is. It's a folder. Now, what does this look like physically? So I'm going to go and I want to see this in Explorer. Let's see what this looks like in Explorer. Well, it kind of looks exactly how we would have expected, right? So CA, Durham College. Inside Durham College, you have this, and then there's a utility folder. Remember, we talked about this. The folder structure has to mirror the package name, right? So what if I want to move my Vector2d and my random vector inside of there? So let's just drag and drop, see what happens. Okay, it says move specified classes to directory, right? It says search in comments and strings, search for text occurrences. What does this mean? What is it going to do? And you can preview. I want to show you the preview here, what it's going to do. Vector2d 0. So Vector2d 0, everything looks the same. You can decide to do it or not. If I do refactor on the left, right, it's actually going to move things over. And then take a look what happens here, right? So now that I've moved my random vector, right, inside of my utility package, IntelliJ renames it for us. Look at that. Package.ca Durham College.utility. So that's the package name now. Same thing with Vector2d. Vector2d package CA Durham College utility. Wonderful, right? And then under main, that's in the core package, right? So if I go into main, and if I scroll up, you can see that my main package is package.ca.Durham College, and I need to do an import because now I've moved my two files, Vector2d and random vector, inside of a utility folder. All I'm doing is telling Java that, hey, I'm looking inside the utility folder for random vector and Vector2d. However, there's another way of doing this. What if I just did something that looks like this? Is that allowed, right? Like some kind of wildcard, right? Is that still going to mess me up in some ways? Like I want to get all, the star means get all the objects from inside of there. And if you look here, it says replace with single class imports. We can go back if I really want to. That's what it's suggesting, as opposed to everything, right? If I want to have, this is everything in the package, right? And notice that it's not giving me any visible errors, so no syntax warnings. It's not saying something like, hey, you know, we got a problem with what you're trying to do here, right? So if I hover over Vector2, right, vector itself, but if I hover over Vector2, it says that ca.Durham College.utility Vector2d extends object. Okay, so that's pretty cool. And let's see how this works. If I was to run this thing, does it work still? And as expected, as we hoped, it still works the same way. So if I say something like 3, 4, and then 10, 20, that's our first point and second point. We can see that the random vector now is between 6.8 and 12.15. That's the random vector, or the first random vector. And then the second one is going to be something larger, so let's say 20, 30, and as well as some kind of negative number. Let's go like minus 20, minus 30. Right, so you see that we have minus 20, minus 30, and we can see that these things are right here. There's the random vector now, right? And we can see that we're getting a magnitude from the first random point of 13.94, magnitude of the second random point of 18.706, and the distance between the two, right? If you subtract these two things, because one is in the negative space, right? As an example, is 4.789. That's the distance between the two. Because look at the first random vector is 9.7 and 15. That's one of them, right? 9.7 and 15. And the other one is 6.8 and 12. So it's not very far away from each other. And that's why it's suggesting 4.789 in terms of units, whatever that unit number is. Okay, so it works. That's what I'm trying to prove here. So we're good, right? And all we did was move it into utility. Okay, are you with me? All I did, Nicholas, was I grabbed the files like this and dragged and dropped it into utility. First I created the utility package, and then I dragged and dropped them in, and then it refactored everything for me. But if you wanted to do it, it won't let you drag and drop. Make sure you're in the SRC folder to do that. You can't do anything in the out folder or in the lib folder. You've got to be in here. So let's suppose I want to make another, can I move main? What do you guys think? So main right now is inside of CA Durham College. But let's suppose I wanted to make another package, another namespace, so that main is in something called core, right? The core package, right? Let's just do that. So again, I'm going to CA Durham College, and I'm going to go to new, and I'm going to go to package. And the new package I'm going to make is called core. So this is the same structure here. This is just for you, Nicholas. So this is core, and then I want to drag and drop main. Can I drag and drop main in there? What do you think? So drag and drop like this. Drag and drop. Now it says this. It says I'm moving it to core. It's going to search to do its changes there. It's going to refactor all the links and everything else so it works. Now this is interesting because main is my entry point for my entire application. So I want to see if this is going to work. Refactor. So here's main, and it's inside of CA Durham College.core. Notice that I still can import CA Durham College utility. That seems to be fine. And if I run it, then I should be good. I am good. All right. So why bother doing this? Why split it up into namespaces like this at all? Well, like it said in PowerPoints, and I didn't read them, but you can read it for yourself. It won't let me. My layout is different than yours. Okay, I'm sorry, I don't know what you're experiencing, Nicholas. Maybe we'll talk about it after. Yeah. But one thing to note is this: whenever we have a larger project structure, a much larger project structure, then it becomes much better for us to drag and drop and create this different structure. Why? Because then what if I want to have a name of a class that's very similar? Let's say, for example, a vector class or something like that. Like example, I want to have my own vector class. Instead of calling it Vector2d, I want to make it vector, right? Just like Java util vector. Look at that. Java util vector, right? Java util scanner, right? So Java is the, because the top level directory, util is a directory inside of, well, actually, it's not like that. It's the other way around. It's kind of backwards, right? But let's take a look at how this set us up, right? So CA Durham College. Let's take a look at our file structure in our Explorer for a second. So source. So CA is the top level, right? And then inside of CA we have Durham College. Inside Durham College we have two files, core and utility now. Core is our main, right? And utility is where we have random vector and Vector2d, right? So that's exactly how we think. Top level, middle level, lower level. And these almost like a folder structure, a folder within a folder within a folder. Okay, and then here we're specifying the class that we're trying to import. We can specify individual classes, or we can use the wildcard star to kind of get everything, right? This is okay if, again, if you don't have a lot that you're getting in. If you do have a lot, like there's a lot inside of your utility package, then you may want to specify something like this, scanner and vector. For example, if I said java.util.star, that's a lot to import because there's a lot in the utility package of in the framework, right? So again, I would recommend that you do individual stuff when you need to. But notice we needed the import, okay? What if we didn't have the import? What if we didn't have this? What would happen? Would somehow things figure themselves out? And the answer is no, right? Because we're inside of another package, and when you gotta tell Java and the compiler how to link everything together, that's how it has to be. So Nick, one thing you can do to, if you wanted to catch up, is you can make your own folder structure, and then you can, copy and paste from outside, right? If you really wanted to, right? So remember that this is a mirror of what it looks like on our, if I open it up again in Explorer, so let's say I want to show an Explorer here. If I do that, and I'm in an SRC folder and CA Durham College core, and let's say I want to move this out of core, like physically. So let's not look at it right now. So I can, first of all, good idea would be to close this stuff down. If you're doing moves outside of IntelliJ, watch what's going to happen. So let's say I want to move main back into Durham College. So I want to cut it. Again, I'm using the my Explorer view, and back into Durham College. I'm putting it out there and paste. Okay, so I did that, and I did it outside of IntelliJ. All right, so now take a look at this. It's out here, right? But we have issues, right? It says it can't, this doesn't match. CA Durham College core. Well, that's not the current package that I'm in. Remember, the first line of all the classes that I've made so far must have the package name, because Java is a class, class first framework, right? And I need to kind of tell it where I'm in, right? So I can't really do this. This has to be renamed because I did it manually. It has to be renamed to Durham College, and then we're good again, right? Once we've done this and I save, then we're okay, right? Notice also that this is red, right? Main.java. Why? Because it says edit run configuration, my edit configuration, it's looking for main in core. That's the main class. And remember I told you this is the entry point, and I've moved it manually. So I need to change this here, my run configuration, to match what I'm looking for, this. And once I've done that and pressed apply, then that would fix part of it. Now, why else do we have this? Because it says it's like highlighted in red. It's like red, red, red. It's bad. Everything is bad. So why? Well, because we're not tracking, right? We're not doing the tracking part here. And it says externally added files can be added to Git. Always add is what we want. Once we say always add, now this becomes blue again, right? Blue means we're good. It's added to the Git structure. Otherwise, it won't be tracked if we move things around. Okay. And again, you may have decided not to choose that option, but I've chosen it because, I mean, for our little examples, it's not a problem. So that's another way you can do it. You can do it manually if you really want to as well. You don't have to do it automatically. Okay, let's try it again automatically. So I want to move it back. First of all, let's run it, see if it runs now that I've moved it around manually. And yeah, it does, right? Like as expected. But let's move it back in there. So again, I'm dragging and dropping it right back into core, and I refactor. Now it gets renamed, and I can run it. And again, you're going to see that we're good to go. Okay, no problem. Packages, in a nutshell. That is really a very high-level view of what packages allow us to do. It allows us to compartmentalize our structure for our code, and what we can do is be organized. And I think organization is great because when it comes to organizing our code, then you want to, especially in a larger project, it can be very stressful if you have every class in a single folder. You want to break it up, right, so that it makes sense. And usually the names you give your packages should make sense. Like, for example, my core functionality is main. That's where main is going to be. Maybe I'm going to have another core class or something like that that I need to call upon, right? And maybe a main structure or whatever. The other thing is that random vector, although it's a utility, right, random vector is really a singleton, right? And it's like kind of a little class to help me, get stuff. We could also have another structure. For example, in our previous life, I should say. Let's bring up Visual Studio for a second. Here, in our previous life with OOP, right? So let's look at some earlier, when this thing decides, when it decides to let me do my thing. If I go back to an earlier lesson that we had together, I'm just going to scroll back here with all the stuff that I've been working on. But way back, we did OOP Lab 5, right? Like way back there in 3200. This again is using our cannot be opened. Sure, no. Let's open it up manually for myself. So let's go in there. There you go. Nelson's in. So yeah, let's go here, and you can see that in earlier lessons. So let's say earlier, like lesson 4-ish. Lesson 8 is when we started doing Java, but lesson 4 is when we were doing things with C++. Let's open up that C++ project for a second. And if we do that one day, and we open up in Visual Studio, again, I'm pointing this out. We had professors and students and all this kind of stuff, right? This is what we had last time. And I talked about how to bring some of this in. Well, whenever we do includes, that's kind of like importing, right, in Java. That's one thing it does. What we haven't done, we didn't practice a lot in C++, was namespaces, but you guys should have already done that kind of stuff as well. And this is not the folder I wanted. Let's just close this off. I wanted another one. Just a moment. I want to bring off one that I can show you, because I want to grab that stuff that we did, kind of like what we did before. I believe this stuff, because this is an IntelliJ, I'm pretty sure. Yeah. So I think we did it. I think I may have had it inside of your in-class exercise that I wanted to test with. So bear with me here while I do that. So I think, if I'm not wrong, I had it inside of our in-class exercises for, yeah, here it is. Here's Lab 5. So way back. And if I'm not wrong, did I include Lab 5? Just want to make sure I got this one. It may not be the lab, maybe my in-class exercise. Yeah, this is my Vector2d. So yeah, inside here in my Solution Explorer, I also have a math library. This one. So what I want to do today is I want to do two things. I want to bring this math library. We're converting. One of the things we do a lot is we convert from one language to the other, as an example. And I want to bring this library here into kind of into what we did. We're doing with Java from C++. So that's what we're doing. So these are some static floats, and I want you to help me, all right? Because I'm trying to understand how to do this, right? So here's my header files, math.h, and I'm also going to have my mathf.cpp, right? So this is what I want to duplicate. A lot of it is right here. And by the way, let's for you to help me do this, I want you guys to look at the information I've shared with you online. So let's go up to our Derm programmer, where we have some examples, and up online here, then there should be, for in-class exercise, like something like 6, if I'm not wrong. I think that is still our object. We have our Vector2d and our math. This is up online, so this is another thing we can use. In-class exercise 6, which where we did our math library. So here's the math library. Okay, so you have access to it as well. I want to be able to bring this, right? Bring this stuff into, as much as possible, into Java. And this is an exercise that we do a lot in programming, where we have an existing piece of code and we want to transfer it from one language to another. All right. And this is an exercise for us for packages as well as for some inheritance and stuff like that in a second. So this is what I want to do first. So, okay, now that you know where the files are for you, how do we do it? What is our first step? So if I'm looking at my files, my file structure here, and if you have access to the in-class exercise that you did with me, this might be easier as well. But I want to do something that looks like this. I want to have these constant floats, and I want to use epsilon and all these different things. These are like constants that I want to have in my math library. So I can't really do one-to-one. I have to kind of build it manually. Let's do it. So first of all, where would we put our math library? Would I put it inside of utility? Would I put it in core? Would I put it in its own? What do you think? What do you think? What would you do if you're going to structure this? If you're working for a company, what do you think is the best thing for you to do? And I'm looking for your opinions, guys, because you're the developer. I can definitely guide you, but what I'd like you to do is I want you guys to come up with a structure. And I'm just going to take 1 second to shut my door. I'll be right back. Alrighty, I'm back. All right, back. So what would you guys do? What are your thoughts? I may have to call on people today because you guys are so quiet. I'm gonna go in order. Ahmed, my friend, what would you do if I was gonna take my math class, Ahmed, and put it inside of my structure here in Java? If I was gonna restructure it, what would I do? How would I set it up? What do you recommend? You can come on the mic or you can talk. It's up to you, or chat. Ahmed? So, not sure. Okay. Well, let's take a anyone else have any suggestions or thoughts? Math class goes into the utility, I think. I would put it into utility. Sure. Okay, we can do that. So let's make a math class. We'll put it in the utility. We'll make a new Java class. We can move this around, right? We'll call it mathf just to keep the same structure as we have before, right? I really don't have to. I can call it math now because guess what? It's inside of my own package. So it's not the math package that I'm using for Java, but my own math. However, it's always safer if I want to move this around or if I put it into another space that it's different than a class that's already been made. So let's just call it mathf. So that's the first thing. So now it's in the utility class. Automatically what's happened is it's created a space for us. It's put it inside of its package. And now what we want to do is start thinking about how do I do this? How do I do this? I could do final float, this kind of stuff, right? And notice that this stuff is actually, if I go to the mathf.h, these are static const floats. Static const floats. Now, this is a library, mathf, right? And I'm going to recommend to you that there's a difference between a singleton and a static container class like this, all right? The singleton gives us a single instance. Here, our mathf, again, there's another way we talked about last week of creating a singleton and not allowing stuff to happen. Here we have this stuff, and I want to do the same structure as we have here. So, first things first, I know that I'd never want anyone to instantiate my class. So this is an example of, I'm going to put in something like static container class, which is different than what we did before with our, it's going to ask me to do stuff. No. is different with that we did before with our random vector. We had a random vector singleton, right? That's different. One thing we did with our singleton is we did a couple steps. One thing we did was we made our default constructor, right? Here's our default constructor. We want to make this private, and I think this is also the right thing to do for our static math class. We don't want anyone to instantiate an object of type mathf, even by accident. So one way to protect it is just to make it private. So private mathf, right? And that's it. That's good enough to make it private. And I recommend it looking like this. So what this does is this protects the mathf class from being instantiated. We don't want that to happen, right? We don't want mathf to be instantiated. We just use it as a container class, right? So next, now that we have that in there, we can start putting in some stuff. All right, so again, we can copy paste. So if I go back over here, we have all these. Let's grab all these things. And let's see what happens when we put them in. So static, const, float. There's no more const. We can't use const. So we want this to be public. Remember? Public static. See how we've written. And this is final, right? And what it says is, if I just start with this, it says variable epsilon might not have been initialized. All right, so this is where it's like complaining, because we have to initialize it with something. So again, we're going to go back to the other side, which is, because again, this is not C++. We know that it's going to be this. That's what our thing is going to be. Can we do that here in this space? Right? Yeah, we can. And this is what you would do. You would kind of make it kind of look like this. Public static final float, right? So let's do that with all of them. So public static final, are going to replace all these, right? Wherever we have static and const, we'll do one of these. So this is the first step to making our class the way it's going to be. And then we want to put values, because it doesn't accept having no values. I'm just going to grab these values and see if they just work. Right? Let's see what happens here if I do that. Is it going to complain? As an example, probably not is the answer. Probably not, right? So make sure you just copy paste. Again, you can find this stuff. Now this is weird. All right, so limits infinity, and we're going to come back to this one, but I want to grab this one first. So here's what I want you guys to do while you're watching. I want you to see if there is an infinity number that we can use. Oops. An infinity number we can use, right, for to replace infinity and negative infinity. Is there something like that? Right, what do you think? I would put in, can you paste it in the chat? Nope. Kafkan, you got to go up online. Go to github.com/Durham Programmer, and it's right there. I want you to practice doing that, because that's very common. All right. You have access to all my code there, and instead of me copying and pasting in the chat, it's going to be too much. Especially so much. There's a lot. All right. So if it was only a few lines, no problem. All right. So how do I do infinity? So can I use? Is there a Java class? Right. So Ashok says double positive infinity. All right, for this. And where am I getting positive infinity for? From the double. So I can say something like, is there? Do I have to use double like this? Double dot. And then if I start typing, is there something like that? Positive infinity? Yes, there is. I can use this. How about is there a float positive infinity? Float class? Because we want to make it a float, right? There is. So positive infinity is what we want. And this would be float negative infinity. So that makes my life easy. I'm happy, right? That's going to make my life super happy, because you know what? Now infinity and negative infinity, when it comes to mathf, I don't have to go float dot and then have this value here, right? I don't have to do that. These are just shortcuts or short forms for me when I want to use my mathf class. Cool. So I've got those pieces done. Let's continue. All right, so now I want all of this. Sine, cosine, blah, 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 whatever. And these are all going to be public static, right? And some of them where I have const are going to be final. All right, let's see if we can do that. So all I'm going to do here is I'm going to grab all this. Let's try that again. Grab all this. Let's go all the way to the bottom here. And I want to see if it's possible that I can grab everything that I have here in C++ and just paste it in here. So paste. And I got lots of errors, but I'm not worried because we can get rid of these, a lot of them, with us going through and replacing const with final. So let's do that first. Static cast got to go away, but we'll start off with that. And anything that says math f : that's got to be gone too. So let's get rid of that first. Anything math f : So if I do a control R, right, I want to replace. The thing I want to find is math f : and I'm going to replace it with nothing. All right, so let's replace all. Bam. So that's all done. First part. Next, I want to replace all consts. Anytime we see a const anywhere, right? It's going to probably replace this. Const space, right? Const space, anything like that. I want to replace with final space. Okay, I want to do that. See if that makes sense. If that works even. Replace all. All right, so that may not work, but we'll see. There might be areas that you see now we got more or less better areas there. Static casts, we're not going to static cast, but static cast float, I just want to float, right? So it's going to replace, let's look at static cast. So static cast, and again, I want to put in the exact thing I see. So float, I want to replace it by float, right? That's how it should be, right? So let's replace all. And then notice it says sine. These are math signs. We'll go back there in a second, but let's just figure out all this static cast stuff. So instead of static cast double, we'll replace it with double. So again, we'll do the same thing. So static cast double, because we don't have static casts, right? Bunch of double. We'll replace it with double, and replace all. A lot of errors gone. Look, there's a lot of places where there's no errors anymore. But there's also some errors where I have something like this. Didn't quite capture this part because they're split over two lines, right? That's not a big issue. I mean, some of them I can just do again, right? So, or I can just replace it myself manually. It's not a big deal, right? So if I missed that one, okay, no problem. Well, I'll fix it. But you can see that there are going to be some areas, right? And I can use this, by the way, to hover over any of the areas that I want, you know, to go through here. So any bool, is there a bool type in Java, you know, as an example? Well, there isn't, right? It's Boolean. So let's do the next one. So I want to say anything that has a bool space, I want to replace with Boolean, right? Replace with Boolean, replace all. So let's see. Oop. Let's undo that change. I meant Boolean space, replace all. Right? So that's more errors gone. We're getting better, right? And there's other areas here. Static cast int. I gotta replace those too. So let's try that. Those are a bunch of them. So again, anything that says static cast int, I'll replace it with int. Okay, replace all. Cool. Got rid of a lot of errors now. Okay, now we need to replace all these math functions, because these math functions here are from C++. So how do we use the math library as an example in Java? What is the way we do that? So if I do something like cosine, right? Or do I have to do math.cos? Is that how it goes? I got to be explicit, math.cos, right? And the answer is yeah. right? Mark math dot and then square root, right? And that's how it would work, right? So we need to replace everything that has lowercase sign with math. It says strict math. We don't want to do that. Math dot sign. Okay, so let's do that. So again, I'm looking for anything that has sign, right? So sign, anything that has sign in it, and with a bracket, right? Now look, it says a sign with a bracket, and I'm going to get into trouble here, so because this is already got sign in it, so we got to make it so it's slightly different. Right now, one thing, it says match case, it says match words, so I'm only going to look for sign, match case, and word. So it can't be a sign, just sign, right? So match case and word, and I'm going to replace it with math.sign, and let's see if that fixes the problem. Replace all. Math.sign. Right, nice. Let's replace everything that has cos with math.cos. Replace all. Anything that has tan, you're getting this, right? With math.tan. Replacing all those functions because basically we're recreating stuff. And anything that has a sign, I'm not sure if this is right. Math.asign. I don't think that is correct, but let's see what happens. Looks okay. A cos, arc cosine with arc cosine. Replace all. A tan with a tan. Replace all. A tan 2. Replace all. Square root. Replace all. ABS. Absolute value, right? Replace all. And we got a few more errors. Let's skip to them. So this one, power. Okay. With math.power, does that exist? Let's see. Replace. Yeah. Exponent. Okay. And I want to ask you about this exercise when we're done. And log. So a little bit tedious, but hey, you know. And log 10. Let's see if that exists. And ceiling. Now this, I'm curious. Place all. And floor, which is kind of a rounding type of way of rounding. And let's see if we have round and math out round. Guys, no errors. No errors, guys. And we did it. We replaced the math library here, right, with everything we had before, right? So, and one thing to note is that there's all these displaced, you know, kind of curly braces. You know, is there a way that we can kind of reformat all this stuff? Wouldn't it be grand if I can kind of select everything, let's say up until about here, and somehow reformat or anything like that? Is there a way of doing that? And because that would be nice, right? I mean, you know, I want to be able to somehow, now it says folding, it does folding. It says analyze, right? So it does all those things. So when I right click, okay. Generate, show it, and file, and then local history, and a bunch of other stuff, but it doesn't really do what I want to do. So I'm not happy with the format. And this is a copy paste thing that happened, right? And but it'd be really nice. It'd be awesome if we could just reformat the entire file like this, right? So, you know, clean up my code, please. Okay, yay! Look at that. One line, one click. And it's all good. Now, I'm not happy with the curly braces being on top of each other, but they're way better than what they were before, right? So, pretty cool. Right. Okay, so that's pretty good. We have all those classes in place. We have one big file. That's how Java works. We don't have interfaces like .h files and so on. But notice what we did. So I went right here, right-clicked, and I just said, hey, you know what? I want to fix that file up, right? I want to reformat the code. And if you click on that again, it says, okay, I can optimize imports. I can arrange my entries, right? You know, what happens if I rearrange entries? What does this do? So rearrange entries. So, okay. Rearrange entries. You know, as an example, it doesn't look like I've done much in terms of rearrangement, but right? So nothing much happened there. And it's kind of done what it has to do. So if I go to, again, reformat code, it says optimize imports. I can certainly do that. Optimize imports. Let's see what it does. There's no imports, right? But CA Pack Durham College utility is here. Cool. All right. So I want to be able to use this when it comes to some of the things that I want to do. And a lot of the stuff that I can do, like sine, cosine, like these custom things that I'm going to be doing with, let's say, this library, which is kind of an offshoot of the regular math library. Minimum and maximum. We did min and max, right? So we did float mins, and we also did float maxes, right? And I want to be able to do min and max. I want to use my min and max library in my main. So going back to main, remember I had this idea of, or somewhere I was using min and max to kind of get the random range, right? I had a random range function that I was using. So if I go back to random vector is actually using min and max, but I'm using min and max, math.min and math.max, and I want to use my own math functions to do this. Let's replace our functions with the ones that are here. So one, I want to import our math. So I want to go back into my import package, and I want to say what we had before, ca dot, and see how it starts bringing up code hinting. Durham College dot utility dot, which one? Math. Now the great thing is I don't have to do this because here's something else I want you to think about. I'm already in the utility folder, right? So I don't have to do that. MathF is something that I have and that I can use. So when I go down here with math.min, and remember we know that in my mathf.java we have a capital M min and capital M max that we can use. So therefore it should just be a simple replacement, yeah? Like this. So I want to do min, right? But doesn't know what I want, right? I meant mathf.min, right, is what I want. Mathf.min. And it says non-static method min cannot be referenced from a static context. We're still not quite done, are we? Right? This is what I want, but I can't do it yet. Okay, so let's see. We're going to keep this error here to test with. Back to mathf. All right, so we're still missing some stuff. So these, I'm trying to access min, and it says there's a problem. Why? Because this is public static floats. If it's float space like this, I'm really doing public static is what I want to put in front of it. So I'm going to grab this public static stuff. It doesn't have to be final, right? So public static, and I'm going to start pasting. Public static float, public static float. And all of these things, I can't do it. Copy replace is not going to help me because there's some other places that have floats, right? But I'm just going to do one of these. And as we go down, public static int, public static float, it disappears, that problem, right? Notice that went away. I'm trying to access the member, right, without me accessing. So this, again, this is a container class for a bunch of functions, and there's nothing wrong with doing it this way if you have a bunch of methods that are static methods that you want everyone to access in the global space, but instead of putting it in the global space, we're putting it inside of our own package, which actually protects everything. And that's the beautiful thing about Java, because it's so safe when it comes to the way we structure stuff. It's not going to put anything in jeopardy in terms of scope, right? So that's a good thing. Cool. So we've done all these replacements with public and statics, right? And now let's see if we go back to random vector. Does it still have a problem, or what's happening here? Oh yeah, no, math F works. How about if I just did min now? Is that going to work? Does it know what that means? Well, yes and no is the answer. So if I did math F dot min, then it knows what I want, math F dot min, and I think that's what it wants, right? I don't have to import because I'm inside of the same package, but I still need to call the kind of the package name, math F dot max, unless I use something else up there. All right, and math F dot min and math F dot max. I'm using my own min and max, right? Okay, why am I doing this? Because I want to see what this looks like when I start doing replacements, okay, for the things that I'm doing. Okay, cool. So I'm using my own package. Does this still work? Now I'm physically using mathf, right? So as before I wasn't. Let's run it. And it looks like we're okay. Let's do a 10, 20, and then 30, 40, 50, 60, 70, 80. And we're going to see that it worked, right? So it calculates stuff like before, right? Distance between the random point and second random point, does all those calculations for us, and it didn't seem that it had a problem. It even suggested a random vector between 53 and 77 between these 2 points, 50 and 70, 53, 60 and 80, 77. That worked okay, right? And the same thing goes with 10 and 30. It suggested 13, and 20 and 40, it suggested 22. So pretty good, right? So it kind of worked out for us in terms of the way it was working. Okay, so that is replacement. We've talked about our packages, right, and everything else that we got in here. Pretty straightforward. Okay, what about mathf? Mathf has a lot of other functions here, right? So arctangent, ABS, and power, and floor, and round, and a bunch of other stuff. Clamps, and lerps, and move towards, and repeats, and delta angles. I would love to have a random range that I could access from anywhere. So it doesn't just have to be built into my random vector. I don't like that. I think it's best to put it in something like this. So I want to program something where I'm saying, okay, I want to get random, but I want to say mathf dot random range, right? And I want to be able to plug in any number I want, right? Any floating point number or any integer number, as an example, and I want to create those functions. Can we think about ways of making that happen here? So let's program this together, all right? So it doesn't matter where I put it. I'm just going to put it here near the top, right? So that way we can keep track of it, because there's a lot of little functions we put in. And then we'll put this up on GitHub after. So let's start. So public static. I want to call it, what is it going to return? The first type is going to return a float. So I want to say random range, and I want to take two floats, a final float, right, min, and a final float max. Okay, from min to max, that's what I want. And it's going to return some kind of random number between min and max. That's what it's going to do. Okay, how do I do random numbers in Java again? Let's go back to random vector. Random vector uses this private random mrand. All right, so I create an mrand first, right? And then what I'm doing, and I'm using java.util.random in order for me to do that, I'm going to have to probably access that again, right, in here. Because what I really want to do is I want to say something like, okay, mrand.nextFloat and blah, blah, blah. This is the correct thing for min and max. I want to copy this, and I don't want to have this kind of stuff happen over and over again. I want to be able to have flexibility where I can use my random range anywhere I want, right? So that's the kind of stuff I want. Cool, cool, cool. So this is the structure that I'm looking for. Now I got to figure out, can I do a private random range, something random temporarily, so I can do this random dot next float, you know, kind of thing, because I want to do the same structure. So again, math F, right? I'm going to go in here and I'm going to say that random, right? So Alt Enter is going to, I want to, there's a one thing to do. I can include, or it says exclude, right? But random, what I want is I want to call something random, right? So it says, do you want to do it? And I want to press Alt Enter, right, to do that. So it's going to include Java util random from the Java util library, right? So that's the first thing. So first I make a random kind of object, right? And then the next thing I want to do, let's look in terms of this. So first I created here, I made it so it's part of my class. Here I don't need it part of my class. I'm going to call it every single time I call this. This is my plan, right? Where I pass in next float, right? So I'm just going to grab this thing and I go back to math.java and put that in and replace mrand with random, right? So random dot next float, and it says may not be initialized. Okay, cool. So where did I initialize it in this? Did I initialize it somewhere? Well, yeah, inside of here I said random is equal to a new random. Let's just do that inside of my math class. So we can do it in one line. Random is equal to new random. We're going to make a new random object, right, where I say random.nextFloat. Max x and min x and min plus min y is like I'm taking min and max minus min. Okay, so that kind of did it. Float random x, it's not really float random x anymore. What I'm actually doing is I'm going to return this. Return this. Do you agree? Is this good enough? What do you think, guys? Check mark if you agree, X if you don't. Yeah, I got some agreements. That's good. We can check it. You should be able to check it and run it and see what happens. I also want to make one just like this, right? And I want to overload it, but I want to do it with integers. So I want to get random integers as well, right? So I want to make this int. And it's random range. I want to get two ints, int min and int max. And instead of next float, I want to get next int from max to min plus min. And is that okay? And the answer is yeah. Right? We'll return an integer instead of a floating point number. Notice that the use of final, which replaces const. It's a copy paste replacement, really, at the end of the day. That's what it is. Okay. All right. Looks like it's good. Let's check it. We're going to use random range, mathf.random range for our random vector class. So instead of random vector making its own rand, let's refactor. So what we're going to do here is we're going to say that random x, we're going to take the min, right, our min x and our max x, and we're going to pass that into our random function. So we're going to say, let's do it here first. So we're going to say that float random x is equal to, again, mathf.random range, and we're going to go from min x to max x. Min x to max x. Okay, and that's what it's going to look like now, random range. So we don't have to do this calculation here, and we don't need to do this here anymore. We can do here. This is so a replacement for what we had before, right? And we want to do the exact same thing with random y. So float random y is equal to mathf.randomRange. I'm going to pass in min y and max y, and get rid of this. So min y and max y, right? We got those two values, random x, right? And this is nice. This is very nice. But there's one better thing than this. But we don't need this anymore. So we don't need to instantiate a random class, right? Oops. We don't have to instantiate a random class, right? This thing. We don't have to do this anymore because we don't need it. We don't need this at all, right? Because we're doing it somewhere else. So it makes our class a little slimmer, but it makes sense because our random vector shouldn't really be doing the random part. It should be somewhere else, inside of a utility function somewhere. All right, let's see if what we did works. We're just going to run it and see if we get some errors. And again, we'll say 5. I will start 10. 10, 20, 30, 40. We get a random number between 10 and 30, which is 10 point something, and then 20 and 40, we get a random number of 21. Pretty low. Okay, 20, 30, 30, 40, 50, 60, 70, 80. Okay, so we get a number between, again, 50 and 70. The number is 53. And we get a number between 60 and 80. The number we got was 73. We're pretty good. That's pretty good. Again, the distance is 67.871 between those two random numbers. So again, that worked just great. All right. But wouldn't it be nice if, right, we had not just this random or math Java using random range, but wouldn't it be really nice if we could generate a random vector from the vector class, right? Why would we want to go out and generate a random vector here, right? Where I can simply just generate a random vector here in my Vector2d class, right? And the random vector should really be part of my class, right? So, you know, I want to be able to do that. A random vector between two vectors is what I'm saying, right? So I want to kind of put it in here as opposed to, and it should be public and static, right? As opposed to using my random vector class. Random vector classes worked so far. We made it a singleton. Yeah, these are nice things. But really, this part here is what we want to lift out of here, right? And put it inside my Vector2d. Why? Because this random vector is only random Vector2d. What if I wanted to make a random vector 3D, random vector 4D, random vector whatever? It's too specific, right? This name, random vector, doesn't mean much, right? It can be any vector, and it may be confusing. So what I want to do is I want to port this thing over into my Vector2d class. So let's grab this, copy it, and go back into my Vector2d class, right? And we're just going to put this at the bottom this time around. So at the bottom, we're just going to paste it. And where it says public final Vector2d, and then create Vector2d, right? I'm going to make it public static Vector2d. Instead of create Vector2, we're going to say random vector. So Vector2d.random is what it's going to be. So it's going to be called random. So just like we had distance, dot, and a bunch of other functions here, in this particular case with lowercase, random is going to take two vectors, start and end, and going to come up with a random Vector2d using the random range class. It's a direct drag and drop. Okay, now it also says, if I hover over, it says duplicated code fragment 10 lines long. Okay, so it says show all duplicates like this, and it's going to pass into where it's looking at the two possibilities. Look at random vector. Look at that, lines 29 to 38 and 200 to 209. It detected that for us in IntelliJ. So we don't care because we're going to get rid of random vector class in a second altogether because we don't need this. There's nothing new or nice that we need to do about this class. We just used this as an example class that was pretty contrived last week. So let's get rid of this class altogether. We're not going to need random vector anymore after this, right? So, so the safe thing to do is just come in here and just delete it. Delete. And if I delete it, we're going to start having these issues, right? But that's okay, because we're going to replace it. We're going to do a drag and drop or a replacement with our Vector2d mathf random range, right? Or mathf random, which is what we put down here somewhere. Or maybe, did it get removed? We can undo that, can we not? Oh, random range. How about Vector2d? Vector2d is where it is. Sorry, Vector2d random. Right, so this is where it's going to be. Vector2d.random is how we're going to use it now, and otherwise everything remains the same. Okay, here's mathf in Vector2d, right? And what we're going to do is, my problem now is main. Main, you know, it doesn't compute with what we want to try and do, right? It doesn't compute. So if I go down here, then we get to this random vector instance stuff, right? And yeah, that's not going to work anymore. I definitely want to store a random Vector2d in there, but what I need to do now is change this to something else. It's going to be Vector2d dot random, right? And that makes more sense. I want a random Vector2d, right? If I was going to do something else, like, for example, a random 3D, Vector3d, that would make sense too. And that is the only thing, really, just other than spaces, I'm going to change at all. And let's see if it works now without having that extra class. So run. And we'll make 2 points, 10, 20, 30, 40. It does the numbers, 50, 60, 70, 80. And we're going to get a random number again between 57. So again, let's check these numbers. 50 to 70, that's computing. 60 to 80, that's also very good. And then we're going to get random values. So this is good. Drag and drop replacements for what we did. Okay, good. This is a great place to put it up on GitHub. I'm going to go to commit. I made all these changes. You can see I removed stuff and I moved things and I did all kinds of stuff. I'm going to say added mathf class removed random vector. Okay, that's what I did. I'm going to commit and push, and you guys should have all that up on online in a second. So why did I go through this exercise with you? Why? Why did I bother doing this? Well, there's a couple of things I wanted you to pick up from this. One is the idea of packages, which is what part of what we're doing today, right? The other part is what we need to do on a regular basis from one language to the other. The underlying motive here was, how do I take a C++ class or a C# class and put it into Java? How do I make it work? What are the analog statements? When I mean analog, means the things that are the same from C++ and Java. How do I convert from one language to the other? It's almost like I'm talking two languages at the same time, kind of thing, or I'm translating from one language to the other, right? And it's not that difficult, as you can see, right? There were some little hiccups, but for the most part, it looks nice. And what we have is a much more useful class. Okay. Are you with me? Check mark if you're with me, X if you are not. I got some check marks. 2 check marks out of the small amount of people that are here today. All right, thank you for that. A couple check marks. Kafkan says, suddenly I feel more bilingual. Yes, you are. Thank you for that. Actually, if you think about it, when it comes to languages, the structure, once we start thinking about structure of language, again, both these two languages, Java and C++ in this case, they're both C-oriented or C-influenced, right? So because they're C-influenced, they're very similar. Curly braces, semicolons, statics are the same. Public is pretty much the same. It's just the way it is. I mean, again, Java is way closer to C# than it is to C++, but there's a lot of things that Java does that C++ does. For example, their getters and setters are very C++ like in Java, whereas C# has its own getter and setter structure, right? At the same time, C# can overload operators like C++, but Java cannot, right? Java has its own thing, the own way of doing things. So these are the differences between one language and the other. C#, is it private or public by default? It's private. Java, public, right? So these are the things that we have to consider, right? And you know, and the way we do references and so on. So again, there's some differences between one language and the other. Also, one thing is, notice that in Java, we can't do struct. There is no structs in Java, right? I can do a class though. I can do an inner class. And I use a lot of times inner classes, and you can even do anonymous inner classes, right? And we'll talk about maybe anonymous inner classes another time. As structs, you can kind of use like these little structures or whatever. Okay, one last thing before we go. I want to make a Vector2d class. Hear me out. And it's going to be contrived, a contrived example. I don't want to make its own, right? I want to derive from Vector2d. I want to pick up all the things that Vector2d has, and I want to do very similar things in Vector3d. Okay, now, I have to warn you that this isn't regular, right? It's not regular because Vector2d in the real world doesn't inherit from Vector3d. Vector3d doesn't inherit from Vector2d. It's its own thing, right? But let's suppose I wanted to do that. I wanted to practice inheritance a little bit. How do I do such a thing? So in my utility class, obviously is where it's going to go. I'm going to right click and make a new Java class. We're going to call it Vector3d, right? So 3D vector this time around. Vector3d, I want to inherit, and like I said before, the way I do that is I use the extends keyword in Java. Extends from, what do I inherit from? My Vector2d class, Vector2d, right? So now that I've inherited, I have to take care of a couple of things, right? For example, in my Vector2d class, I have some things that I got to worry about, okay? And the things that I got to worry about are all my Vector2d constructors. So let's see, what does that look like, you know, as an example. So here is setters, and here are my constructors. I've got these, and there's private methods and public methods. Hey, you know, let's organize our stuff like this too. So Vector3d, let's do that. So let's say, you know, some kind of, you know, private instance methods, variables, right? Some kind of public properties, some kind of constructors, private methods, public methods, and maybe static methods. Something like that. These are all things that I would probably do. All right? Something like this. I know that before in Vector2d, we had a private float x and y. I want to have an additional thing is a private float z. So I know that that is something I need to have here. So let's put that in. So private float z. All right. Private float z. So that's the one thing I need. From my public properties perspective, I'm going to have a getter and a setter for this. So again, right click. I'm going to generate. I want to generate getters and setters for my z. Okay, there they are. That's a pretty quick way of doing it. Cut. I'm going to put these inside of where I want them. Paste. And now I have get z and set z that are right here. All right, so that's my getters and setters, right? My constructor. So just like I did here. So on this side, I did my getters and setters. I did getters and setters on the other side, right? As an example, they've been done for me, right? I also want a set method, and I want to overload or override my set methods because it's going to have the same thing. Set X and set Y, these are all unique, right? But these are going to be different. So I'm going to grab these, and I'm going to go back into Vector2d, and I'm going to override them, right? So now you can see that it says that there's a little symbol here. It says overrides, right? Overrides. You can see that it kind of marks those as overrides. So X, Y, and of course I want final float Z, right? Is it an override or an overload now? Final Vector3d. I want to take in a Vector3d. Actually, yep, I want to take in a Vector3d. And let's make some, so this makes sense. This dot Z is equal to Z. Notice that I can't do this because I don't have access to those variables. So one way to do it would make it so that I set those variables on X and Y if I know they're going to be protected as, as part of a class. If I know I'm going to inherit, I might think about making X and Y as protected. I might, right? So in my Vector2d, if I'm inheriting from it, instead of making these private, I could make these as protected. And what this does is it gives any class that inherits from Vector2d the ability for me to access its private members, right? So if I go back to this now, you can see that those remarks go away. I have access to that direct, right? And in this case, it might make sense because it's almost like I'm truly extending what Vector2d can do to a third dimension. So this might be okay if I did it this way. All right. So I've got an additional two setters that I can use for Vector3d. One that takes a Vector3d. I also want, let's fix this. This dot Z is equal to Vector.Z. I also want to do the other one though. I want to have a Vector2d. What if someone only gives me a Vector2d? Is that enough? So I want to say that what if someone gives me a Vector2d? This is an override, right? So I want to grab these two things, but I want to set vector this dot Z to 0, right? So if I don't get a vector Z, if I only get X and Y, then set Z to 0. Okay, this is what this does. And so I could, if I put at override, right? Notice that it gives me a bunch of options for this to which one I want to override. So set, let's say, for example, if I start typing at override, it does that for me, right? It says copy javadoc and blah, 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 or just set the at override in there. So at override is what I want, this one, which flags this as something that I'm overriding, right? And I want to do the same thing. It's different than an overload. An override is different than overload in that it's taking the original one and changing it for Vector3d. Okay. I also want to overload. So I'm taking a Vector2d. That's wonderful. What if also I want to overload this one? So I want to grab this, and I want to say, what if someone only gives me 2 instead of 3, right? This is another overload, right? So I want to say that, well, then I'll set 0, I'll set Z to 0. If you don't give me Z, I'll set it to 0. So then I can do that too. At override, right, is what I want to put in here, okay? I'm just marking it. I'm annotating it so that it's clear to the compiler what I'm doing. All right, pretty cool. Constructors. Let's see what my constructors are in my math vector.2d, right? So I have 2 constructors, 3. I have 3 of these constructors. Let's grab these 3. I want to redo them, right? So, and now when I do this, there's going to be some issues, and we're going to talk about this as well. So, paste. Can't call these 2D. We're going to call them 3D. They're still not complete. They're going to give me errors. And let's talk about what they need to do. So I'm going to set a Vector3d 0. I don't have a Vector3d 0, or do I? Well, I do actually. Vector3d 0 is going to give me X and Y as 0. And this works because Vector3d 0 inherits from Vector2d 0, where Vector2d gives me x and y's are 0. And when I do this, set, because set is doing this up here, it's overriding me getting a Vector2d instead of a Vector3d, because that's what's really going to happen. And then I can set this in. So this would actually work. All right. Here's something else, right? My Vector3d 0, do I have to set up my super constructor? My super constructor has to be satisfied, right? So it actually is, because what I can do is I can explicitly say super and pass in whatever I want. Like I can call this super constructor just like this, because that's really what it is, right? I could do that, right? But when I do that, then I'm also doing this, right? So it's kind of like I'm killing two birds with one stone, because this one actually sets up the z axis, and this one sets up x and y if I do it this way. But because we're not calling this, because this has a default constructor, I don't have to do this, right? And we're going to do it anyway. All right, next. How about this one? So final float x and y, and I want to take a z. So final float z. This is a very common pattern as well, right? And I want to satisfy my requirements for my superclass. So I'm going to pass in x and y here, right? And I'm only going to set z. So I can set z, right? Set z to what I want, which is just going to be z, right? Passing in the z value. Similarly, I can do the same thing here with setting x, y, and z to 0. I don't have 3D 0, but I'm going to override these in a bit, and they're going to be perfect. But again, this is optional. I'm actually doing it twice when I'm going through here. This is good. This makes sense to me. Okay. All right. What about this part? So what if I get a Vector2d? Yes, I should be able to set up with a Vector2d, and I should be able to set up my setter that way. But maybe what I want to call is super, and I want to pass in the Vector2d in here first. So vector, because that's okay, because super calls the super constructor, right? So it satisfies the base class constructor first. And then I know I'm only getting a Vector2d, so that means this would be 0, right? So I can just set up, there's a couple ways to do this. I can just set z, right, with 0.0 if I really want to. Or something else, right? Another method to do this. But for now, let's just set z. So we don't have to do this anymore. It's already been set. We'll say set z to 0. We can do that too. That's perfectly acceptable this way. Notice I'm using the setters and not direct access. Again, maybe I'm going to have something in the setter at some point that does that. You know, this kind of stuff. Here, I'm setting everything to 0, but I've already got my super set to x and y. This is set to 0 immediately anyway. So here I can do the same thing. I can just say set z to 0. That's the same as what I just did earlier, because x and y is going to be set to 0 here, right? And how do I know that? Because if you look at the Vector2d from the other thing, if I don't pass anything in, it passes in 0 to x and y, right? So that's what this does. Again, clever ways of doing this. You can do this different ways. Now here, I'm passing in a Vector2d. That's not as common as passing in a Vector3d, so let's do that as well. So another overloaded constructor where I can take in a Vector3d, right? And if I take a Vector3d, then what I can do is I can set up vector. I can't pass in a Vector3d to my superconstructor because I don't think there is a Vector2d, Vector3d translation. That's going to error out if I try to do this, right? So what do I do here with my superconstructor? Well, I can just pass in vector.x and vector.y. I can do that too, right, in my superconstructor. Right, because that's okay. Right, I can decouple, you know, the x and y coordinates and pass them in. Right, and then I can set z to vector dot z. I can do that. Again, irregular. Normally I would have Vector2d on its own, right? But we're inheriting. So private methods, I'm not going to have any private methods right now that I want. Public methods, is there anything that I want to override? Doesn't make any sense. For example, my toString method or something like that. Well, let's go back and take a look at my Vector2d public methods and see where I need to change stuff. Well, yeah, this needs to change, right? Add, subtract, multiply, all of this needs to change. These need to be overridden as an example where I can use vector3s to add two vector2s together. Remember? Because I can take a vector2 or a vector3 because I'm inheriting. Okay? And this is where the problem is. Semantically, it doesn't make any sense. So let me just grab all this and put them in here. And instead of me taking vector2s, I'm taking vector3s. We're just going to go back down here and do the same things. And you get what I'm doing here, right? So I got vector3, so now I can do the same thing with this dot set z, and I can set this dot get z, right? Plus RHS dot get z. I got the extra thing in there, and that's fine. And then once I have that pattern, I can just copy paste to here, where I replace this with a minus, and replace this with a multiply sign, and replace this with a division sign. I'm not doing any kind of checking whatsoever if it can divide by 0. Okay, so that is all of our simple methods: add, subtract, multiply, divide. This is replacing our operator overloads, let's say in C++, and we still have many of them that we didn't do. Okay? And there's a case that we see here, definitely, for some kind of template, which we're going to see later on. How do we convert our Vector2d or a vector into a template? Just like we've done, we call them generics in Java, but that's okay. Let's just kill this. We don't need this anymore. Okay, so I'm just going to go back to this, and so I want to grab all this stuff and do the same thing. I know it's a little bit tedious, but I'm making my 3D class, so what the heck. So paste those in. Okay, equals. I'm comparing Vector2ds now. I'm not comparing Vector2ds. Get magnitude, square magnitude, set scale, and scale. All right. So this is where I'm comparing. So what I want to do is I'm going to say the only way it's equal is if x, y, and z are equal. And I'm just going to grab all of this, and we'll make it so that it is z. So x, y, and z are equal. That's how we can do if it's equal. And for this one, what I want to do is when I get magnitude, I want to get the square root of x plus y plus z this time around, which is different than what we had before. Ooh, hey, look, there's a place where I can use my mathf dot square root, right? Mathf dot square root is something that looks like this, right? Where I take in a value and I want to get the square root, right? And I can probably do the same thing now that I saw this. Let's go into my Vector2d where I've got that stuff, and I'm going to say mathf dot square root. So I want to use that instead of the way we did it before, right? Any kind of mathematical functions, I want to go through my math because I've vetted those things, right? All right, I mean, vetted, it's a big word. So I get square magnitude again, it'd be the same. So we're going to say, you know, plus this dot get z times this dot get z, right? So there's your square magnitude. Set scale, that's pretty easy. Set scale is just going to multiply the scale that we got, a floating point scale there, by everything else. So we're going to say that set these plus you know, this dot get z multiplied by scale. So I want to scale up the z-axis as well. and set scale with a Vector2d, well, that is okay, because then we can do, we're going to do a symmetric scale here, and this is maybe be an asymmetric scale there, where I can set this dot get z multiplied by scale dot z. So kind of like a different way. Why is this having a problem here? Thank you. And that does everything else. So that is modifying what we had before from a 2D to a 3D. Now notice that this is an override, this is an override, this is an override, but this is not an override, because I can theoretically set scale 2D, right, where I want to scale only the x and y values, but not the z values, right? So that I don't have to override, but these ones I should mark as override, at override, right? And same thing with this. Oops. At override. I'm marking them so that the compiler knows, and so you know when you're looking at my, no, it's not what I wanted. That when you're looking at my stuff, that it is, I've overridden these things from the original, right? Because I'm adding additional, an additional term in here. Okay, static methods, and then we're done for today. I know this is a bit of a journey, but we're talking about inheritance, and this is what I'm doing. I'm actually using inheritance and a bit of polymorphism that we're doing here as well, where I'm changing stuff. I'm not using interfaces yet. I'll introduce those again next week, just so we can continue with this whole analogy. Normalize and Vector2d normalize, those are pretty cool, as well as my string method. Those are the last ones we have to do before we get into these static methods, which are going to be really quick. All right, so normalize. Okay, so we're going to override these ones, because this is going to be the exact same thing, but it's only going to work for 2D or 3D, right? So how do I normalize something in 3D? So I want to get this dot magnitude, so I get this. Once I get my magnitude, I want to take my magnitude if it's greater than this, and then it says set get x divided by magnitude, get y divided by magnitude, and of course I'm missing get z divided by magnitude. And what this does is it provides a number between 0, it changes the numbers when I normalize between 0 to 1. All right, that's what it does. Otherwise, I want to say get 3D, set 3D 0. I'm going to get back to this in a bit because we need that. Get normalized for 3D is Vector2d, so I want to make a new Vector2d, right? And when I pass in get z, so I want to pass in a regular thing. This is a copy of what I'm making of my current object. Then I normalize it and I return it. So this is good. This is okay. The only thing it's missing is the z value, right? So I want to kind of put this in there, and something like, do all that here. So comma z plus this, and that gives me everything I need for my toString methods. So my toString method is now overridden as well, x, y, and z. And now my static methods. And there's a lot in here. I can't possibly do them all because there's many, but let's cover the ones that I can do really quickly, the ones I use, which is all this. So all of these are overrides, right? Because even though they're static, they need to have the same names, right? And there's also a couple missing, forward and back, right? Which are, if we're going to use a three-dimensional space kind of analogy, right? All right, so here, Vector2d 0, right? So that's what we're going to do, Vector2d. That's what these are all going to return. At 0, 1, left, right, up, and down, it's going to return Vector2d. it's just opening them up. That's not what I wanted, but it's okay. It's going to happen anyway. All right, obviously this is going to be 0, 0, 0. And this is kind of our first one. This 1 is 1, 1, 1. So that's pretty simple. Left is same, except this is 0. And this is the same, except this is 0. We don't have to do this, obviously, but that's okay. And this is down. And one thing that's different for this one, we also have forward and back. So let's grab 2 of these, and we'll call them forward and back. So this is forward and back. And forward is, everything is 0, except let's suppose that forward is positive, where we're going 1 in the Z direction, right? And back is negative, so we're going -1. Let's suppose this is our coordinate space, and so we can do forward and back as well, right? And so we have an extra thing here. Now this satisfies the requirements when we said math f.0 up here. I could have used up here to set all this to 0 in my constructor. I could have done that, but I'm not going to do that right now. But this sets us up nicely for everything that we need to do, forward, back, and all that kind of stuff. All right, what about our other Vector2d stuff, lerping and all this kind of stuff? This is more challenging to do 3D lerp. We need to, our formula is different. I'm not going to go through a formula now. Same thing with dot product, distance. Look, math dot square root. It should be math f dot square root, right? Anytime we do that is something we want to use, and it's giving us a bit of an error, right? It says, math f dot square root. Well, it says you're giving it a double, right? We're taking in a double, and we're returning back a float, but I'm passing in a double. This is where I'm passing in my double precision numbers, right? Because these are doubles, right? Delta x and delta y are doubles, and I need to be able to take that as my precision. So can I make another thing to make this work? Of course I can. I can go back into my mathf, and inside of here where I do square root right now only takes floats, but I can make it so that it also takes doubles. And so here we'll make it so it's a double float final double, and it's going to return a double back out, obviously, where I'm passing in a double. I'm passing it in as a double, squaring it, and returning it out, right? Which is taking care of my problem when it comes to our Vector2d. If I want to change it to math f square root, all right, so it'll work the exact same way. Math f min max, all that works well, and I'm not going to change anything else. But that is an example, guys, of my Vector3D inheriting from, and you can see the challenge that I had to go through to retrofit what I have in my Vector3D from my Vector2D, right? Again, I haven't used it, and we're running out of time here for my example to use my Vector3D, but really Vector3D is everything that Vector2D is plus. Okay. Now, there are some issues. There are some issues, right? Because there's some stuff that Vector2D does that Vector3D also does, right? And we don't want it to do that. Like, it's not going to compute some things that Vector2D does, right? And so we can either override them, but one thing we can't do is we can't stop a user from using a function that doesn't make any sense. So example, if I went into my main now, and I said, well, you know what? I want to make a Vector3D. So I said, I don't know, var my vector is equal to a new Vector3D, right? And I want to pass in, or maybe I want to say Vector3D 0, Vector3D. Oh. 0. Okay, I can do that, right? This is returning a new Vector3D. It's almost like a little factory for me to make a new Vector3D, yeah? And then, if I did that, and if I said my vector dot, well, these are all the things I can do, right? I can set x and y only. I can set x, y, and z. I can set a 2D vector, pass in a vector 2D or a vector 3D. I can add two vector 3Ds together, divide two vector 3Ds together, get magnitude, set magnitude, normalize, set scale, and all this kind of stuff. And the things that I haven't changed, for example, I can also add two vector 2Ds together. Right? I can add two vector 2Ds together. And since I haven't overridden them, the vector 3D allows this functionality. And this is where we run into some contextual issues. How can I add two vector 3Ds with or vector 2Ds with my vector 3D dot add and divide and equals, right? Shouldn't be able to. This is where vector 3D deserves its own class, or, which is even better, a generic, right? Which allows me to put anything I want, adding together and so on, right? And there's some stuff that I haven't touched, right? As an example, if I go down, that I'm going to have access to that, for example, my dot product and so on. Notice that if I start typing dots, right? Dot is okay, right? I want to get the dot, but guess what it's going to return? I'm going to return it's looking for a vector 2D because I haven't really done a dot product proper with a vector 3D. So until I do it, I'm going to get the old one. I have to override this thing, okay? But I'm just mentioning that it works exactly like a vector 2D, except I can do more. All right, that's really the lesson for today. Any questions around what we've done? So again, today we split everything into packages. We talked about access. One of the things we talked about for access was protected versus private, and you've seen that kind of stuff inside of C++. And now you've seen an example of what that would look like on Java, right? 'Cause Java, we just put it protected here, and so on. We've replaced, translated from C++ into Java by making a new math class, right? And we're going to use this math class later on in one of our examples. But here I'm actually, creating our math class, and it's a class that takes some really cool things. This can be extended, and we can also create generics for math, right? For example, min and max, I'm comparing integers and floats. And, well, what about doubles? Can I do mins and max with doubles? What about strings? Can I use mins and maxes with strings? In some ways, there's a case for it, right? It doesn't make sense, but what about mins and maxes with vectors, right? A min max with a vector instead of just a numbers, right? For example, vector 2D, right? Do I have a vector 2D min and a vector 2D max? Do I have that functionality here? If I wanted to kind of make mins and maxes, right? So here I've got distances and everything else. But what if I wanted, is there a case to kind of find the minimum, value or the maximum value of something? Well, there is. If I wanted to sort, as an example, by a vector 2D, create a sort, right? Then I would need something to create an order, right? And now this is up to you how you would set up the minimum. Is the minimum based on the x value? Is the minimum based on both the x and y value? Are you going to compare both to say that for it to know when you compare two variables, right? Or two vectors, how do I know that one is more minimum than the other one? The one that's smaller or lower on the scale. Is it more negative, right? Like there's got to be a case for this kind of stuff, right? Or, and that's the thing that you have to kind of think about. But generics are something that we're going to handle this semester, and it makes sense. It's going to save us a pile of code here because you can see that there is quite a bit of duplication. All right, questions around this at all for your in-class exercise? This is in-class exercise number 11, and I'm going to put this up on GitHub so you have examples of what we've done. Obviously, we haven't finished everything on our vector 2D to vector 3D. I recommend you go through it and finish it up, add the Lerp, see if you can find a formula for vector 3D Lerp for yourself, and then see what happens. Right. So here I'm going to say that we added a vector 3D class. We're going to commit and push, and we're going to go to our VCS tool, and we're going to say just push, git push. We can also go push up here. Again, this week I'm using the VCS. It's built into IntelliJ IDEA, and last week we did an external tool like GitKraken. All right, that's it for me, guys. Any questions at all before we stop? All right, I'm going to stop recording now, and I'll take questions from people that are here. All right, any questions from the guys that